Hey guys, welcome back to Consistent Code. So today's problem of the day is Geek and strings. What the problem says is Geek has a list li consisting of n words and two query strings. Now what we need to do, we need to find how many strings in the list li has a string x as its prefix. For example, just consider this list of string. So this is the list of string and we are given these queries. For example, now if I consider this query, then I can see then we need to check in how many strings in the list this query is a prefix. So we can see in this string, AVR can be found as a prefix. Similarly, in this string, AVR can be found as a prefix. So I can say this query string can be found in two strings. So hence for this output is 2. And similarly, if you consider this geeks, then you can see there are three strings. One is geeks for geeks, another one is only geeks, and the third is geeks thrill. In all of them, geeks can be found as a prefix. So output for this is 3. Similarly, you can check for all of the other cases as well. So now I hope you have got an idea of what we need to do. So now how to solve this problem. To solve this problem, we are going to be using Trie data structure. Now, at this point, I would recommend you to have a basic understanding of Trie data structure if you do not have. But even if you don't know Trie structure, I will be explaining it to you. But obviously, I'm not gonna implement. I'm just gonna walk you through the code and explain you how we're gonna insert these li in this string and how we are gonna solve it. So if you want to learn Trie, I recommend you to first learn it and then watch this video. But if you think you will be able to understand, then you can continue watching. So now, having said that, let's get started. So basically, what is a Trie? Let me just give you an overview. This is like a Trie data structure. As you can see, this sort of thing is a Trie, which initially is having a root, and these this thing is the node of a Trie. Now, suppose I want to insert these two things, consistent and code. So how can I do that? So first of all, let's insert C. For consistent, I will just insert letter by letter. So first, I will just insert a C. So I'll just go here and I will just mark a letter C. So this will be my C. And let me just mark its frequency. And I will mark the frequency of character C as 1. And this is character C, right? Now, similarly, so what I can do, I can just, uh, you know, copy this and now we need to insert this O. So how can we do that? I will just create a next node in which I'm just gonna insert an O like this. And I'm just gonna replace this C with an O. So that becomes an O here. So similarly, now you can insert an N here. And once you have inserted the complete consistent, it should be looking something like.
Alright, so now we have inserted consist in our try. Now how am I gonna insert this code? So see, first I'm gonna stand at this root and I'm just gonna check if C exists. So C already exists, so I'm just gonna update its frequency to 2, which I have already done. And then similarly we need to update the frequency of 1, also the next letter O to 2, so it remain updated to 2. Now we will check the next letter, which is D, and we are just gonna, since we do not have any link from node O to D, we are gonna create a link. So to create a link, what you can do like this, you can just complete this D and E insertion. Now, after we have inserted consist and code, and also this is not cons in the query, it should be code. All right, now it's correct. Now, how we are gonna check that CO is in our try? So we are just gonna start from searching from our root node. We are here. Now we will check its links. So it is only linked with C. So we will check for our query string it's CO. That the first, if the first letter is linked with this root node, then we will find that yes, it is linked. So we are just gonna move to this link node. Now we are here, and we will consider the frequency f equals to 2. We will always consider the minimum frequency. Suppose we are checking CO, then if we find all the letters, then the answer will be the minimum frequency of all these letters. If any letter in this is having a null node, or the node does not exist, that means the frequency of complete letter, complete word will be 0, because that does not exist in our try. Now we will check the next node, the links with C. For now, for link O. Now link O already, since it exists, we will move to node O, and the frequency will become 2, right? So CO exists, and CO comes 2 times in prefix for our lists. Now let's check code. For code, CO already exists. Now currently we are having CO's frequency as 2. Now as soon as we find the next link D, we will have frequency updated to 1, because we are gonna take the minimum frequency. Now we will move on to the next. We update our node as D. Now we'll check its links if the next letter is connected to it. So the next letter is E, which is also connected to this. So now we will update our position to E, and we will update the frequency also as minimum of the current frequency and the frequency of E, which is 1. So final answer for code will be 1. It comes one time in our list, as you can see here. Now what if our query string was codes? Now S does not exist in this trie data structure. E is having no link with any S. So even if code is having a frequency of 1, for codes the frequency would be 0. Now let's see how to implement this in our code. Now I have already completed this problem, so I'm just gonna walk you through the code, because if I code this completely, then it will just increase the video length. So first of all, we are just gonna create a trie data structure. So this trie data structure consists of a node. As you can see, a complete trie data structure is consisting of one root node, and this is our root node, and then it should be having the nodes. These are the nodes, and we can create some functions to insert a word in our try, or to count the, if it exists there, and or even count the frequency of that word in our try. And now let's see what should be the part of this node. The node should be consisting of the frequency of that character in that node, and the links which can be the next 26 letters. Out of those 26 alphabets, how many links we have. So you can see the node consists of frequency and the 26 links, which will be initially set as null because we are not having any links. Whenever we find, we will just create a link to that position. And this is our increase count whenever we want to increase the frequency, and this is get count, which will return us the value of frequency of that node. The next part of trie data structure is the root node, which is this, and this is the constructor part. And as I told you before, there are two functions to insert and count the frequency of a word. To insert, as we have discussed here, how we are inserting, we will stand on the root node and start from the root node. Now for the word, we will start from the first letter. We will see if this word's node is connected to the root node or not. If it is null, that is, there is no existence of such a node, we will create a new node. And if it existed, or now that we have created, we are just gonna increment its frequency by 1 by calling the increase count function of a node which we created above, which what it does, increment f by 1. And then we are gonna move to the next position. Like if we in inserted this c, then we are gonna come, we were standing at root, now we are gonna update our position to node c, right? So that's it. Now similarly we can implement a count function, which should we will again start from the root node, and for a word start from its first character, and we'll again check the same thing. If we have a node having connected with this first letter node, and if it is not present, then the complete word frequency becomes 0, as we have discussed here, that if in case of codes, even if CODE exists and S frequency is 0, then the frequency of complete word becomes 0, because we take the minimum frequency. And here we are doing that only, we are taking the minimum frequency, and then we are updating our position to the next node which was linked, and then we can simply return the count, which is the answer here. And initially we initialize the answer as infinity, or a very big value, you can say. So now this is the complete try data structure. And now what we are doing, we are just creating an array, or you can say a vector of size q to store our answer. Then we initialized a try data structure, then we inserted all the strings in our list in our try, and then we are just calling the count function of our try to update the value of ith element of our array. And after that vi should be storing our answer, and then we can return v. So basically what we did, this was the list. First we inserted all these strings, and then we queried all these strings from our try data structure. Now let's submit this code. Okay, I have already submitted this code, but let's see again submitting it. So it's correct. And I hope you liked the explanation. And if you did so, make sure to hit the like button and subscribe to the channel. And I will see you tomorrow with the next problem of the day.